Have you ever thought about this? There are things in the universe that don't need to aim at you, don't need to come close to you, don't even need to notice you exist. They're just there. And then you're gone. Earth is gone. You and I are gone. Every city, every ocean, every person you've ever loved, vanished in 0.001 seconds. Today I'm taking you to see the 5 most terrifying objects in the universe. Not science fiction. Not made-up stories. Things that exist right now, in some corner of the cosmos, for real. Starting from number 5, I promise, with every step forward, your blood runs a little colder. Are you ready? Number 5. Let's start with something that sounds completely harmless. A white dwarf. White. Small. The name even sounds a little cute. Don't let it fool you. A white dwarf is the core left behind after a star like our sun dies. About the same size as Earth, but carrying roughly the same mass as the entire sun, like stuffing a whole star into a ball the size of our planet. Grab a teaspoon of this stuff and hold it in your palm, 5 tons. Okay, so far it's just insanely dense but not really a threat, right? The problem is, it's never alone. A white dwarf usually has a companion star nearby. And then it starts doing one thing, stealing. Slowly siphoning gas off its companion, little by little, no rush, like a patient vampire drinking in the dead of night, one quiet sip at a time. But there's a limit to how much it can take. When the mass it accumulates hits a critical point called the Chandrasekhar limit, roughly 1.4 times the mass of the sun, boom. A Type Ia supernova explodes, releasing in just a few seconds the same energy the sun would produce over 10 billion years of burning. If this happens within 60 light years of us, Earth's atmosphere gets stripped clean off. No fire. No tsunami. Just the atmosphere, gone. If you were an astronomer and spotted a white dwarf quietly feeding off its companion star, what would you do? Tell me in the comments. The white dwarf was just the appetizer. What's next doesn't explode. It just exists. Quietly. And that kind of quiet is scarier than any explosion. Number 4, the magnetar. Let me give you a number first, 10 to the power of 15 Gauss. What does that even mean? Earth's magnetic field is about 0.5 Gauss. Your fridge magnet, around 100 Gauss. The most powerful MRI machine in any hospital, less than 100,000 Gauss. A magnetar's magnetic field? 100 trillion Gauss. If one of these is 1,000 light years away from you, and you're sitting right here, the atoms inside your body are already being warped. Electron orbitals deforming. Molecular bonds snapping. DNA unraveling. You start coming apart at the quantum level. You don't even have time to feel pain. The magnetic field alone is enough. But a magnetar has a second trick. On December 27, 2004, a magnetar designated SGR 1806-20 experienced a starquake, like an earthquake, but happening on the surface of a neutron star. It lasted 0.2 seconds. In those 0.2 seconds, it released energy equal to 250,000 years of the sun's total radiation output. Where was this magnetar? About 50,000 light-years away. Even so, the blast directly disrupted Earth's ionosphere. Multiple satellites malfunctioned. Radio signals around the world went briefly dark. 50,000 light-years. 0.2 seconds. It affected Earth. If it had happened within 10 light-years of us, scientists say we wouldn't have had time to know what hit us. Magnetar or black hole, which one scares you more? Comment A or B and tell me your gut feeling. Number 4 was that intense, so number 3 should be a little gentler, right? No. Number 3 is stranger than both. Strange in a way where, after you hear it, you realize the word dangerous just doesn't cut it anymore. Number 3, and this might be the first time you've ever heard this name, a quark star. To understand it, let's start with neutron stars. A neutron star is a more extreme version of a white dwarf, with the mass of 1 to 2 suns packed into a radius of just about 10 kilometers. The size of a small city. 1 teaspoon weighs over 1 billion tons. And a quark star is compressed one level further than that. Inside a neutron star, the pressure becomes so extreme that neutrons themselves can't hold together, they get crushed. The smaller particles that make up neutrons, quarks, are freed directly, forming a state of matter called quark-gluon plasma. This state only existed at one other moment in history, 1/1,000,000th of a second after the Big Bang. The interior of a quark star holds the form of matter that existed at the very birth of the universe. And it's out there somewhere right now. Okay, so far this is still just bizarre physics. So why is it ranked number 3? Because of a theory called the strange matter infection effect. Strange quark matter has one terrifying theoretical property: once it comes into contact with normal matter, it may convert that matter into strange matter and keep spreading. Like a drop of ink falling into clear water, except this drop turns the entire ocean into ink. If even a small piece of strange matter were to touch Earth, Earth wouldn't explode. It wouldn't burn. It would be rewritten, layer by layer, from the outside in, until it became a strange quark sphere drifting silently in Earth's old orbit around the Sun. The good news is, this is still theoretical. Scientists are still debating whether strange matter actually behaves this way. But here's the thing, it's just theoretical doesn't always hold up in a universe like this one. If you could safely observe any one of these 5 objects up close, which would you choose? Tell me your reason in the comments. All top 3 are in. Number 2 is different, no what ifs. It's real, at the center of our galaxy, right now. Number 2, the supermassive black hole. I'm not here to tell you the story about getting stretched into spaghetti. I want to tell you something closer to home. At the center of the Milky Way, about 26,000 light-years away, sits something called Sagittarius A star. Its mass is 4 million times that of the Sun. Most of the time it's quiet, occasionally swallowing a cloud of gas, letting out an X-ray belch. But in 2019, astronomers watched it suddenly brighten by 75 times in just 2 hours. Like something massive got swallowed whole. Then, silence again. Nobody knows what triggered it. And that's not even the most unsettling part. Here's what is: if Sagittarius A** ever enters an active state and becomes a quasar, it would fire 2 jets of ultra-high-energy particles across the entire galaxy, relativistic jets. If Earth happens to be in their path, gamma rays would pierce our atmosphere within seconds. Ozone layer, gone. Global mass extinction. No meteor. No explosion. Nothing. Just the eye at the center of our galaxy turning to look our way for a moment. The good news is, Sagittarius A** is currently calm, and its jets aren't pointed at us. That's number 2. Now, number 1. I need to be clear about something. This isn't just an object. It's an event. An unstoppable, non-negotiable, zero-warning event. Number 1, the gamma ray burst. When a massive star collapses into a black hole in its final moment, or when 2 neutron stars spiral into each other and collide, the energy released in those few seconds equals everything our Sun will ever radiate across its entire 10 billion-year life. Not 100 years. Not 1,000,000 years. 10 billion years, all of it, in seconds. That energy gets compressed into 2 ultra-narrow beams and fired outward at nearly the speed of light. And then what? Then it happens again. Every single day, somewhere in the universe, a star dies exactly this way, sending out death signals in every direction. Today, while you're watching this video, somewhere out there, one just happened. In 2008, detectors recorded the most powerful gamma-ray burst ever captured, GRB 080319b, originating 7.5 billion light-years away. And yet its light was visible to the naked eye. A blast from 7.5 billion light-years away. Seen. With human eyes. If you'd been standing outside and known where to look, you would have seen it. Now what if it wasn't 7.5 billion light-years away? What if it was 6,000? Scientists have calculated, high-energy radiation would penetrate our atmosphere within seconds. The ozone layer would be destroyed. For years afterward, with no ozone protection, every living thing exposed on the surface would face extinction. There's a theory that the Ordovician mass extinction 440 million years ago, which wiped out 85% of all species, wasn't caused by an asteroid or a volcano, but by a gamma-ray burst from somewhere in the cosmos. That may have been the first warning. The worst part is,